All right, I have some time to kill at lunch. Let's do some admin of code. So just finished day 16, so now we're on to day 17. But this time you just feel like you're falling. Situation critical, the device announcer. Bootstrapping process, initializing debugger. Small NL device suddenly unfolds into an entire computer. There seems to be a 3-bit computer. That's 4 bits. This is 4 bits, not 3. What? Oh, wait, no. I'm an idiot. Sorry. 3 bits, 0 through 7. Okay, right. List of 3-bit numbers. The computer also has 3 registers named A, B, and C, but these registers aren't limited to 3 bits and instead can hold any integer. Let me start writing this down. Um, var A long, var A equals 0 long, um, var B and var C equals 0 long. Okay, right. The computer knows 8 instructions, each identified by a 3-bit number called the instruction's opcode. Right. Okay, this is pretty straightforward so far. We just have a mapping of instructions to that. Okay. Computer knows each identified by a 3-bit number. Right. Each instruction also reads a 3-bit number after it is input called an operand. We have 6-bit number that we need to split. Okay. A number called the instruction pointer identifies the position of the program. Except the jump instructions, the instruction pointer always increases by 2. Okay. So var IP instruction pointer equals 0L. I hope that's not a long though, because that's going to be a lot. That's going to be a big program. But right. Okay, so this is an example program, right? Pointing at the first 3-bit number, except for jump instructions, the instructor increases by 2 after each instruction. So it moves 6. Well, it moves 2 steps, or okay. Now let me see what my input looks like first. Okay. All right. I see. Okay. Let me get my input here. So this is going to be my input, and then my test input is this. Okay. Okay. So for now, let's just get the input. So it's going to be lines 0 dot substring after colon space dot 2 int, and that is var A. Okay. Var register B equals, yep, line 1, var register C. Okay. And then var program equals lines dot, or lines 4 dot substring after colon dot split on comma dot map it to int. I'm debating if I want to turn that into a binary string. For now, let's just stick with ints because those are easy. Actually, let's do dot to byte. What's byte is shorter? Okay, 2 byte. Let's save some memory. 2 byte. Okay. That's just going to be annoying to work with, truth be told. 2 int. Okay. So dot two. For now, let's do dot two list. And then we're just going to pass in to part one, register A, register B, register C, and the program. Add these parameters to part one, and then we have var instruction pointer. I just realized I set these all to vars, but they can be vals up here because the thing is that they will be vals in this is going to be initial A, initial B, and initial C. Yes. And then var reg A, reg B, reg C equals initial A, initial B, initial C. Can I not do that? Can I do this with... I can't do that. Okay, cool. Cool. Okay. So it'd be nice if I could just do it with the parentheses, but I get the logic of why I can't. Instruction pointer equals 0. So, okay. I have the basic idea. So now I have 3 operations. So, so we're going to have val enum class opcode and it's whoa. So it's advance going to be pixel. So hang on, this is division. This is bitwise XOR. The numerator is the value in A. The denominator is found by raising 2 to the power of the instruction's combo operand. So an operand of 2 would divide A by that. Wait. The result is truncated to an integer and then written into the A register. Okay, so if it's truncated to an integer, then I actually want these to be in. A divided by 2 to the power of basic. 2 to the power of operand or operand to the power of 2 would divide by raising 2 to the power of the instruction's operand. Oh, this is a pain in the ass. I see. I see. It's already more complicated. and then we store that in A. Bytewise XOR calculates, and the instructions literal. Okay, so there's combo operands and literal operands. Calculates the bitwise XOR of register B, and the instruction is literal operand, then stores it in register B. Okay. So this is going to be B XOR literal B. Okay, A division, B, yeah, right. So BST is calculate the value. BST is calculates the bitwise XOR, no, sorry, calculates the value of its combo operand modulo 8. Then writes that value to B. Okay, so it's just combo mod 8 written to B. The gins instruction does nothing if A is 0. However, if A is not 0, it jumps. Okay. So this is jump not 0. If A not equal 0, jumps by setting the instructor pointer to the value of the literal operand. Equals 0. Okay. Sorry, I was just checking that. And there, I'm just making my notes here so I don't have to keep bouncing back and forth. I'm trying to make sure I understand each. If it jumps, don't increase IP. Okay. Don't increase IP after jump. There's a trick I can do there, which is just set IP to 2 minus the thing, and that might be the easiest way. BXC calculates the bitwise XOR. How is that different of register B and C? Okay. Is bitwise XOR B and C. And where is that written? Then stores in register B. This instruction reads an operand but ignores it. Okay. Operand. The out instruction calculates the value of the combo operand modular 8 and then outputs it. What? Outputs it where? Printing? Okay, separated by commas. Got it. So it doesn't change the state of the machine. Program outputs multiple values are separated by commas, right? For now, I'm just going to say print, and then I'll change if I need to later. The out instruction calculates the value of the combo, right? Combo modulo 8. Print combo mod 8. Right, because I get that. Okay. The BDV is B division, except works exactly. The numerator is still read from A. Okay, so and then CDV. Okay. Is the same. All right. So now, that's my mindset, and this is going to be and these are 1 or 0, 1, 2, 3, 4, 5, 6, 7. Okay, so and then hang on. Determine what the program is trying to output. To do this, initialize the register, then run the given program and calculate the output by out instructions. Always join values. After the above program halts. Okay. When does it halt? If the computer tries to read an opcode past the end of the program, it halts. Okay, so while instruction pointer is less than program.size. And then I'm going to do instruction pointer plus equals 2. I'm just going to do so on get opcode instruction int and this is going to return opcode and when instruction 0, yep, 1, yep, okay, they know what I want mostly. Gotta be careful with the autocomplete though, because it's suggesting things that I actually don't want. Like for instance, that should actually be BST. All right. So we're gonna do when get opcode, and it's going to be program instruction pointer, or in hindsight, I don't really need this extra logic, but still going to do it. Okay, so fun get combo operand, and this is going to take in operand int, and then it also needs to take in, and will not appear in valid programs. Okay, so 4, 5, or 6. Register reg a int. Yeah. All right, and it's just going to be if operand equals 5, then return a. Wait, is it? Sorry, 4. Then return reg a. If operand equals 5, then return reg b. And if operand equals not 7 but 6, then return reg c. I'm curious how it's coming up with the values. Return operand. Okay. All right, so this is just going to be, actually, let's do this. Val output equals mutable list of int, and then we're just going to add it to out, and then we're going to line out for now, and return -1. Okay, so division, it's a divided by reg a equals reg a divided by, does it have times for power? No. 2 dot I don't remember it. Kotlin exponents. Okay, dot pow. So it's value dot pow, which I actually prefer that Kotlin does that. So 2 dot pow, and it's going to be combo pow operand. Why is that a problem? Oh, there's not an int dot pow? Interesting. Oh, okay. There's got to be a built-in one for Kotlin. Three dot two double pow That's that's what I got. Import. Okay, for some reason I didn't like that. When it says truncate to int, I'm somewhat worried about what that means. When it says truncate to int, I'm somewhat worried about what this means. Truncated to an integer, like only because I worry, can that be a negative number, or is it? Do I need to do like mod 2.15 billion or whatever integer.max is? I'm a little bit confused on that. For now, I'll just assume that it means typecast to an int. Does he give any sort of clarification about what the definition of an int is? All right. Well, I'll just run with what I got. Sorry, I'm just getting some quick little email checks in. Okay, so I'm gonna guess that's what I want to do. Wait, the result of the division operation is truncated to an int. Would I want to do like too long and then not to int? I mean, that doesn't really make sense though, because none of my inputs exceed. My register A value never seems to exceed what I would expect. Oh, trunk meaning we division, right? Okay, I get it. I get it. Okay, there's that. I get it now. Opcode is so bitwise XOR. So we treat it like a literal, and so it's going to be reg b equals reg b XOR operand. Actually, come to think of it, this is a perfect case to demonstrate Kotlin inline function definitions, which is right here. There's a perfect case for this, which is here. Because I can reference the local variables, so I can define a function inside of, although in fairness, I want to define it outside of my while loop because I don't want to redefine the function every time, but I can define the function just right here. And it'll reference the var. It's actually quite nice to be able to do this because now I don't need to pass god awful instructions everywhere. Okay, so and actually let's do val opcode. There's a reason I'm going to want this. Equals program instruction pointer. And let's do okay. Then stores it in B. Right. Okay. BST. Calculates the value of the combo mod 8, then writes that value to B. Okay, so equals, why am I doing all of that when I can just, so reg B, here, just to keep it sort of smaller, I'm going to put all these in line. Because they're all just single statements. So reg B is get combo operand mod 8, which I could also do just XOR 7, right? Not XOR 7, and 7 would give me the same result. Might be faster, but I'll test it out later. Okay, and then if reg A equals 0, then we're going to set instruction pointer equal to, is it the literal operand? Yeah. And the easiest thing to do is operand minus 2, so that way I can just do instruction pointer plus equals 2 every time. Although, there's no real nice way, I think, to write that in terms of code other than doing like an if. I don't know. If other people had to read it, maybe I'd do if operation equals jump 0, don't increment or something like that. But okay, so now BXC is B reg B equals reg B XOR reg C. Out.add get combo operand put, dot add. A lot of this is me just trying to make sure that I'm interpreting things correctly, and so I'm going a bit slow with it. But this part I can do, so it's the same operation except we write to B, but we still use A as the numerator. And it's the same operation except we write to C, but we still use A as the numerator. Okay. Let's try this out. Test input. Sorry. Kotlin does take a while to compile, especially when you have as big a project as I have. And I imported a lot of new code because this is my work computer and I haven't used it a bit. Oops, I ran the wrong program. 364. I don't think that's right. Wait, I am sitting here. What? The light in my office sucks. It upsets me and I don't like it. Okay. First task, determine what the program is trying to output. Does output do like mod 8? I didn't realize that. Okay. Out mod 8. Okay. Are we getting the first value to print? We are, but then it stops. Determine what the program is. To do this, initialize the registers, then run the given program, collecting the output after each instruction. Operation operand. And let's actually do get opcode operation. And then we're going to print line IP register A. Let's just do A, $reg A, B, $reg B, and C, $reg C. Okay. So the first thing we do is we do they're doing divide by 1. So that makes sense. 729, yeah, 364. And then we're doing out. The next operation is 5, which is out, correct? Yeah. Let's just double check this. And then we're doing to jump NZ0. So we should be jumping to instruction 0. IP is 4. Oh, A is not. Wait. Did I get it backwards with A with jump? If A is 0, do nothing. Oh, okay. I got it backwards. That's why. Okay, so I get 4. Am I getting the same? 4, 6, 3, 5, 6, 3, 5, 2, 1, 0. Okay. All right, so I can delete these now that I'm confident it's working, and I can do my test or my real input. Like this is one that's easy if you can follow the directions. It's just that there's a lot of them, so I trip up. But I don't want. Let's do. String, and I want to do turn output dot join to string comma. Okay, so what is this? You discover that problem. This program is supposed to output another copy of the program. Fortunately, the value in the register A seems to have been corrupted. You'll need to find a new value to which you can initialize register A that the program's instructions produce an exact. I'm assuming brute force is not going to work. An exact copy of the program itself. Okay. Okay. Obviously, brute force is not going to work. Just obviously not. Right? So we get another program. Actually, let's just return output now. Whoa. I didn't like when you did that. Let's just return output and let's do list int, and then we're going to pass to part 2 everything except this, and it's going to be the program is the part 1 result. And if I were to just brute force this, it would be something like for I in 0 ... int max value, I would do something like why does it not like this? Like dot for each oh yeah, no, I know what I do. For each I, and then I do get part 1 result like I'm just going to run the brute force thing, and obviously it won't finish, and then I'll actually think about how to do it for real, which is reversing all the operations. So we get result 1. What are the orders here? Get part 1 result. I add these register B, and this is going to be something like that, right? And now we run, and then nothing will happen. Index out of bounds. Okay, so Right, we're not doing anything with it. Here we go. Here, let's see how fast this program runs. If I equals, because what I need to do is reverse engineer, right? Obviously, but I'm just going to say if I mod 1000 equals 0, print line I. Honestly, going up pretty fast. But this tells me probably, I'm already into the billions, probably a long value. But we'll see. Actually, I'm realizing the problem is I'm doing. Okay, it can be. All right. I couldn't remember Kotlin if it does the Java thing or if it does the Python thing with equals equals. But yeah, I mean, I'm up into the billions, right? Yeah, I'm up into the billions now. I'm getting up to pretty high integers, and I'm actually I'm getting close to running out. I'm gonna figure out the fast way to do it, but make sure I'm reading this right. In hindsight, I should run the test program first. You know, maybe actually. Okay, so we never actually returned anything. If A needs to be a long, I'm gonna be annoyed. Um, Probably needs to be a long, right? I don't even know why I'm like trying to make this brute force thing work. Hmm. Interesting. Test input seems to enter an infinite loop. Weird. How am I going to detect an infinite loop? Wait, how am I getting an infinite loop with one? I'm kind of curious how I'm getting an infinite loop with part one because I'm obviously going to have to eventually do something about that. Um, I'm just trying to understand this program right now. If A is 1, then the first operation is binary XOR. Also, I now know that this needs to be a long. Var reg A equals I'll just make them all longs. Just make all the registers longs, and now it's even though it's stupid to do it this way. Because I have a feeling that A just basically has to be a long at this point. Okay, but we can all agree that this mod 8 must necessarily be an int, right? Like we're adults here. All right, I don't really know how to handle this other than to say .toInt and just hope that this doesn't cause problems because I mean, let's be honest, if we're dealing with a number that's greater than the limit of an int, we already have a problem. Okay. First, let's just change this back to 0, and we're going to run. The issue is I can tell at this point that A has to be a long. It just does. That has to be a long, and that has to be a long. Okay, we're entering infinite loops again. But that's okay. I'm expecting that with the test input. All right. Let's try What was the solution it gave? This. Okay, yeah, we keep entering an infinite loop, so there's just infinite loops that abound in. What's going on here? Okay, am I misunderstanding the problem? Program outputs a copy of itself if register A is initially. Okay. For example, unfortunately, the value in register A seems to have been corrupted. You'll need to find a new value which you can initialize register A to. For example, blah. Wait, do I just initialize B and C to 0? Okay, hang on. I'm not getting the right behavior. This is what they tell me the answer should be for the test program. Get part 1 result. Okay, this is what. So I'm getting an infinite loop here, and so I'm misunderstanding it's being asked. On my test input, another copy of the program. Is it the same program as part 1? Is that what I'm misunderstanding? So I'm confused. Is this program my output from here? This program outputs a copy of itself. Oh, it's the same. Okay, okay, I see, I see, I see, I see, I see, I see, I see now. I see. I'm passing in. I thought part 1 result was the program that we were then trying to run that program to make a copy of itself. No, we're passing in the same program. Except we're not getting what I thought we were getting. Again, I'm sort of confused here. Like, think I'm missing what's being asked because I'm not getting the results that I'm expecting based upon what the instructions say as I'm interpreting them, which means I'm interpreting them wrong, obviously. Okay, let's do Okay, okay, I see. So, right. Okay. Now I understand. So, for, so it's, hang on. I can be 0 dot dot less than. So I was approaching this wrong. Int dot max value. I know this is a dumb brute force way to do it, but again, I'm going to try. Um, going to be if I mod 1000 equals 0, then we're going to print I, and then from there it's just if get part 1 result I 00 program equals program. Then we want to return I. Okay. Let's just see how fast this brute force approach is. Oops. I'm printing a lot. Print line, and then, but now we're not testing with that program, we're testing with, or we're running with input. All right, let's just see how fast it goes. I'm I'm just mentally too tired at the end of the semester to do the reverse engineer, and I have office hours soon. I am going to do the reverse engineer one way or another. So let me just check something real quick. Okay. Actually, you know what? I got threads. I got lots of threads. I'm going to stop and I'm going to use them. Can I, can I just do a dot like two? I mean, this would be way too big a list to do is the issue. Is there any way to do like dot to stream? Yeah, okay. I'm not gonna mess with it for now. I'm just gonna do this. I'm gonna leave it running while I do office hours, and then I'll do a reverse engineer on stream later. So 17 part 2 not done yet. I'll figure that out. Take care.